So for example number 2 here, we take what we learned in section 7.1, which was creating our system of equations from a word problem, and then take it and add on the information that we know so far about 7.2 in solving the system of equation by graphing, and we put the two together. So here's our word problem. Cassie has a grass cutting business. She charges $12 to cut a small lawn and $20 to cut a large lawn. One weekend, Cassie earns $180 by cutting 11 lawns. So first of all, we need to create our let statement saying what our variables are going to be. I'm going to say, let's say that our small lawns is going to be X, and our large lawns is going to be Y. So what else do we know? We know that she earns $180 by cutting 11 lawns. So we know that she has to cut 11 lawns, which means that if I say X plus Y is equal to 11, that's our total number of lawns. And we also know that she charges $12 to cut a small lawn and $20 to cut a large lawn. So we could figure out a value equation that represents a total amount of money of $180. So that would be 12 times our small lawns plus 20 times our big lawns is equal to $180. So now we have our system of equations. We have our two equations that we can graph on the same grid and find where they crisscross. So again, let's quickly graph those. X plus Y is equal to 11. Now for me, it doesn't say to use X or Y intercepts or not to use X or Y intercepts. I do know that if I'm going to be using anything other than X and Y intercepts, that I have to be careful. Because with this question, there are no such things as negative values. I can't have a negative number of small lawns. I can't have a negative number of big lawns. So I'm only using this quadrant, this first quadrant, in which both the X and Y values are positive. Okay? So sometimes when you're using X or slope-intercept method, you don't necessarily get a value that's going to be able to be plotted in this positive quadrant. Because if that Y-intercept came up as negative, it's going to fall down here somewhere, right? And that's going to be a bit of a problem. So you have to be a little bit careful. So that all being said, I think I'm just going to continue and graph these using X and Y intercept method. So here's my first equation. X plus Y is equal to 11. If I'm looking for my X-intercept, I make my Y equal to 0. This becomes X plus Y is equal to 11, or X plus 0 is equal to 11, or X equals 11, giving me a coordinate point of 11, 0. I do a similar calculation for my Y-intercept. This time X is going to be 0. X plus Y is equal to 0. 0 plus Y is equal to 0. Y is equal to 0. Whoa, back up. This isn't X plus Y is equal to 0. This is X plus Y is equal to 11. So 0 plus Y is 11. So Y is equal to 11, giving me a coordinate value of 0. Whoops, not 0, 0, but 0, 11. So I can plot those points, and I'll do it in red. So 0, 11, and 11, 0. 1, 2, 3, 4, 5, 6, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then draw my line. Look at that. Such a pretty line, which does not cross my grids properly. Y. 2, 4, 6, 8, 10, because I can't count. That's not 11. 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10, 11. There we go. There. Now I have that first graph done. Completed. Let's look at the second one. 12x plus 20y is equal to 180. Change colors. 12x plus 20y is equal to 180. I want my x-intercept. That means y equals 0. Yes, it gets monotonous. Yes, it gets painful, but showing all your work, doing all these steps, this is what ingrains it into your memory. 12x plus 20y is equal to 180. I substitute in 0 for y. 12x plus 20 times 0 is equal to 180. 12x is equal to 180. Divide by 12, divide by 12, x is equal to, what is that by 12? 15, giving me a point of 15, 0. Similar calculation to get my y-intercept, except that means x is 0 this time. Still start with my equation. 12x plus 20y is equal to 180. 12 times 0 plus 20y is equal to 180. 20y is equal to 180. Divide by 20. 20. Y is equal to 9. Give me a coordinate point 0, 9. So there's my x and y intercepts for my second equation, 15, 0 and 0, 9. I can plot those points on my grid. That's 11, 12, 13, 14, 15. And that's 11, so this is 9. Make that smaller, a little bit bigger. And draw your line. There. So I've graphically represented both of those. Look to see where they crisscross. Coordinates of this point here should be the solution to our system. Well, what are the coordinates of that point there? Coordinates of that point are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 5, comma 6, 5, 6. Now, of course, at this point, to test and make sure, we're going to verify those points. So I go verify. Whoa. Palm was on the page there. Verify. 5, 6. Start with my first equation. X plus 11. No. X plus y equals 11. Substitute in my x and my y. 5 plus 6 equals 11. And 11 equals 11. So it's true. So far, so good. I test my second equation. 12x plus 20y equals 180. Substitute in 5 for x, 6 for y, and calculate. 60 plus 120 is 180. 180 equals 180. And that is also true. So we've also verified that both of those equations would hold true with that point of intersection, that solution to the system, of which we found by graphing. Okay, lots and lots of practice coming, so make sure that you get a handle on all of this stuff. You can graph with x-y intercepts. Sometimes it's easier, sometimes slope intercept is easier. Totally up to you. But just remember, in order to get better at this, you need to practice, practice, practice.